Example 7, evaluate the limit as x goes to 1, coming from the right, 1 over the natural log of x minus 1 over x minus 1. So if we tried, if f of x equals 1 over the natural log of x minus 1 over x minus 1. If we tried direct substitution, we would get 1 over 0 minus 1 over 0, which is undefined. So that doesn't work. So, next thing we can do, think about the natural log function. Looks like this. Where this is 1 comma 0. So, as x approaches 1 coming from the right, this is going to be a really, really, really small decimal. So 1 over a really, really small decimal, that's going to be infinity, minus, this would be, just slightly bigger than 1, minus 1, so same thing. This is indeterminate. Okay, so what we're going to do, we're going to do the limit as x approaches 1 from the right, and I'm going to make this 1 over the natural log of x times x minus 1 times x minus 1 minus 1 over x minus 1 times the natural log of x times the natural log of x. So now, I got the limit as x approaches 1 from the right of x minus 1 minus natural log of x all over the natural log of x times x minus 1. Well, we know that this would be indeterminate as well, because it's this equivalent form of that, but what we can do, we can use Lupus Rule. So now the derivative of the numerator would be 1 minus 0 minus 1 over x all over, let's see, this is going to be the product rule, so it's going to be first times the derivative of the second plus the second times the derivative of the first. So now I've got the limit as x approaches 1 from the right, 1 minus 1 over x all over natural log of x plus, if I multiply this through, this would become 1 minus 1 over x. So now, let's try to apply the limit. So if we do direct substitution, I put in 1, this would be 1 minus 1 all over 0 plus 1 minus 1. So this is going to be 0 over 0, which is still indeterminate. Which means I have to do Lopus again. So let's change this to x to the negative first, and change this to x to the negative first. That way, when I apply Lopus, it'll be easier. Derivative of 1 is 0. Derivative of negative x to the negative first would be positive 1x to the negative second, all over the derivative of the natural log of x would be 1 over x. The derivative of 1 is 0, and the derivative of negative x to the negative first is going to be x to the negative second. Now, when you plug in 1, this 1 to any power is still 1. 1 over 1 would be 1, plus 1 to any power is 1. So this is going to end up being 1/2. Example 8, the limit of the natural log of x is x, or to the power of x minus 1 as x approaches 1 from the right. Okay, so if we did direct substitution, this would become 0, this would become 0. 0 to the 0 power is indeterminate, so we can't evaluate it this way. So I'm going to do this. I'm going to let y equal the limit of the natural log of x to the x minus 1 power as x approaches 1 from the right. Then what I'm going to do, I'm going to take the natural log of y, and this limit, I'm going to take the natural log of x as to the power of x minus 1 as x approaches 1 from the right. Then I'm going to apply the power rule. So I have the limit of x minus 1 times the natural log of x as x approaches 1 from the right. Then I'm going to take the limit of the natural log of x all over x minus 1 to the negative first power as x approaches 1 from the right. Now I'm going to apply Lupus Rule. So the natural log of y equals the limit as x approaches 1 from the right, take the derivative of this. So this would be u prime over u. The derivative of the natural log of x is 1 over x. And then u is x here. Divided by, and then take the derivative of the denominator. This would be negative 1 x minus 1 to the negative second. The derivative inside here would just be 1, so now I have this. Then, let's see, 1 over x is multiply the numerator and the denominator by x, you're going to get 1 over x squared. So now I have the natural log of y Okay, I made a mistake here. When I'm taking the derivative here, this is u prime. Okay, so this is u prime. The natural log of x would be 1 over x, and then u is the natural log of x. So this should have been the natural log of x here. And to simplify this, 1 over x over the natural log of x, multiply the numerator and denominator by x, so this would be 1 over x times the natural log of x. So now I have the limit as x approaches 1 from the right, 1 over x times the natural log of x, all over negative x minus 1 squared. So then this would be the limit as x approaches 1 from the right, 1 over x times the natural log of x times negative x minus 1, this would have been negative here, squared. Then limit as x goes to 1 from the right of negative x minus 1 squared all over x times the natural log of x. Now when you try to evaluate the limit, you're going to get 0 over 1 times 0, so 0 over 0, that's indeterminate. So then you're going to take the derivative again, Lupus Rule. So the limit as x goes to 1 from the right would be negative 2x minus 1 to the first power all over product rule. So it's going to be the first times the derivative of the second plus the second times the derivative of the first. Now I have negative 2 times x minus 1. This would be 1 plus the natural log of x. Now when we evaluate the limit, this would be 0. This would be 1 plus 0. So this is 0. Remember, this whole thing was equal to the natural log of y. The natural log of y equals 0. So e to the 0 power equals y. So y equals 1.